finish Neet successfully? Yes, definitely. Because the paper was very easy. And the difficulty level is only 25 easy questions are there, and 17 questions are medium, only 3 are difficult. So come to the physics, this is the level of the difficulty. Now based on this one, 25 easy, 17 medium, and 3 are very difficulty. So it is very easy even for the students, medium students or average students also can score very good score. And the paper is in the level of CAT, though it is a NEET. And let me explain the solutions of this paper for this physics, which is for code H3. Let me start. See that first question. So we have the color code of resistance is given below: yellow, violet, brown, gold. The values of the resistance and tolerance respectively. So here we need to find the resistance for yellow, violet, brown, gold. So here we have yellow, violet, brown and gold. So this is what yellow, violet, brown and gold. See that as we know the color code, BB what? Great Britain versus Great White. Thereafter we have gold, silver, necklace. Now look at this one, yellow. This is the coloring 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And whereas gold, silver and no color, which is 5%. These three colors represents tolerance. This is 5%, 10% and 20%. Let's see. Yellow. Yellow is which is 4. First two colors gives the two digits of a resistor, which is 4 and violet 7 into, and third color represents which is brown, black, brown, multiply plus or minus the fourth color represents the tolerance, which is gold, 5%. Now the resistance value is 470 plus or minus 5%, but from this one that is given resistance and tolerance, which is 471 and 10, which is first one. Let us see second one. Find the torque about the origin when a force of 3 J cap Newton acts on a particle whose position vector is 2 K cap meter. So let us, and it is very easy. Second one, this one, first one and second one. Torque is defined and force is given here. F is equal to 3 J cap meter, whereas position vector which is r bar, L bar and r bar, which is 2 K cap meter, and you need to find torque acting on this point. Torque is equal to r bar cross F bar, but not F bar cross r bar. Now let me write here r bar 2 K cap cross 3 J cap. See that is equal to 2 into 3, 6 K cap cross J cap, which is minus I cap. If it is J cap cross K cap, I cap, but K cap cross J cap means minus I cap. Is it I, J, K. So I cap, J cap, K cap. J cap cross K cap is A cap, but reverse means K cap cross J cap is a minus cap. That is what we have, minus 6 I cap. Then the option is here what? Fourth option. So let us see. Third one. A cylinder contains hydrogen gas at pressure of 249 kilopascal and temperature 27 degrees Celsius, and its density is R is equal to 8.3 joule, mole inverse, Kelvin inverse. Then we need to find its density is, temperature is given, you need to find the density. So let me write given information. Hydrogen gas, for hydrogen gas, pressure. So pressure is given 249 kilopascal, 249 kilopascal, and temperature 27 degrees Celsius. But tell me, take it in Kelvin. So 27 plus 273, that is equal to what? 300 Kelvin. But remember, it is kilopascal. 249 into 10 power 3 pascal. And you need to find here density. But given R value 8.3 joule, mole inverse, Kelvin inverse. Its density is, what is the density? Now, from ideal gas equation, we know that PV is equal to ideal gas equation. Ideal gas equation. PV is equal to what you know? nRT. PV is equal to mu RT. But mu represents number of moles of gas. And remember, we need to know what will be the molecular weight of the hydrogen gas. Molecular weight, atomic mass, which is m is equal to 2 gram. Remember, it is 2 gram, but not 2 kg. Then this is very important. You need to write it in kg. 2 into 10 power minus 3 kg. 2 into 10 power 3 minus 3 kg. Now PV is equal to mass by molar mass into RT. Now if you bring mass by 1 into this side, m by b, that is equal to Pm by RT. Pm by RT. This is nothing but what? Density, mass per unit volume. So which is rho is equal to, just substitute these values, 249 into 10 power 3 into molecular weight 2 into 10 power minus 3 by R 8.3 into 300. Is it? Now how many times is it? 30 times. Now it is 10 times. Now you can see 10 power 3, 10 power minus 1, then 2 by 10, which is 0.2 kg per meter cube. Then we have, which is third option. Let us see fourth one. Fourth one. Two cylinders A and B of equal capacity are connected to each other via stopcock. A contains of an ideal gas, a standard temperature and pressure. B is completely evacuated. The entire system is thermally insulated. The stopcock is suddenly opened. The process is. See that it is a sudden process or a quick process. For all the sudden process or quick process are adiabatic. All sudden process, quick or sudden changes, that is adiabatic. Slow, which is isothermal. Slow means what? Isothermal. Now when the cycle to burst, that is what? Quick process, sudden process, which is adiabatic. Then the option for this one is third option, which is adiabatic. Let us see next one, fifth one. Two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter with negligible mass. The center mass of system from the 5 kg particle is nearly a distance of. So it is based on the center mass of the system. which is what we have two masses, two particles of masses. M1 is equal to 5 kg. So let us take, and one more mass which is M2 is equal to 10 kg are attached to the two ends of a rigid rod of length of 1 meter. The length of this rod is 1 meter. Now there are center mass of the system from 5 kg. Let us take M1 and M2 if it is D is equal to 1 meter. Now central mass of the system which is xcm from first mass which is M2D by M1 plus M, which is 10 by 5 plus 10 into D1. So 10 by 15, 2 by 3, which is 2 by 3, 0.667 meter. But options are given in centimeter. Then what we can write here? 66.7 centimeter. That is 67 centimeter, which is fourth option is the correct one. So let us see sixth one. A ray is incident at an angle of incidence I in one surface of small angle prism and emerges normally from the opposite surface. If the refractive index of the middle of the prism is mu, then the angle of incidence is nearly equal to. So we need to find here angle of incidence. See that? A ray is incident at an angle of incidence I on one surface, the incident ray, and here the angle of incidence I, and it is a small angle prism and emerges normally from the opposite surface. Now the light is incident here and it emerges normally. Normal means from the surface. Normal means there is no deviation and it is I. Remember the relation angle of prism is equal to R1 plus R2. But when we have observed here R2 is equal to 0, even angle of emergence is also 0. Then what we have? A is equal to R1, R2 is equal to 0. Now apply Snell's law. From a first surface. Outside we have A, then mu sin I is equal to mu1 sin I is equal to mu2 sin of R1. Now mu1 into sin I is equal to mu2, which is refractive index of the prism, into sin R1, which is A, R1 is equal to A. But for small angles, what we can write? Sin theta is equal to theta, then sin I, which is I, and mu into sin A is equal to A, then I is equal to mu A, which is the fourth option. Let us see next one. Seventh one. A body weighs 72 Newton on the surface of the earth. What is the gravitational force on it at a height equal to half of the radius of the earth? Again we need to find which is based on gravitation. See gravitation, what will be the acceleration due to gravity, variation of the acceleration due to gravity, the altitude, which is here we have is the height of the object which is very small compared to the radius of the earth, then gh is equal to g into 1 minus 2h bar. But here h is comparable to the radius, then gh is equal to g into r by r plus h whole square. But h is equal to what given? R by 2. But you should not use g into 1 minus 2h by r. You will not get the answer. Now weight on the surface of the earth, w is equal to mg. That is given. Now how much is given? 72 Newton. What is gravitational force on it at that height? Means weight at that height acceleration will be gravity at that height, that is equal to m into g into r by r plus h value r by 2 whole square, that is equal to mg value is by 72 into now r by r plus r by 2 3r by 2 3r by 2 whole square, that is equal to 72 into this will become 2 by 3. 2 by 3 whole square is nothing but what? 4 by 9. So here it is what? 8 times, then 8 fours 32 Newton. So 32 Newton at half of the radius of the earth, the height half of the radius of the earth. Eighth one. An iron rod of susceptibility chi is equal to 599 is subject to a magnetizing field which is H is equal to 1200 ampere meter power minus 1. The permeability of the material of the rod is mu value they are asking. Permeability of the material of the rod they are asking. Is it? Now what we have? What is the relation between susceptibility and permeability? We know mu r is equal to 1 plus chi. Is it? So mu r is equal to what? 1 plus chi. Here chi value is given, then 1 plus 599 which is equal to 600. Is it? But we need to find the permeability of the material. So what is permeability? Mu is equal to mu naught mu r. Mu is equal to mu naught mu r. That is mu naught value we know 4 pi into 10 power minus 7 into 600. That is equal to 4 into 6 24 into this pi value 3.14 into 10 power minus 1. Then what we have here. Now again 3 into 4 which is okay, they have not calculated this up to this pi value. Then 2 into 6 into 4 24 pi into 10 power minus 1, that is 2.45 into 10 power minus 4. Is it? S nanometer and 10 power minus 1, which is second option. Let us see ninth one. So let us see ninth one, which is based on transistor. See that for transistor action which of the following statements is correct. So transistor, let us see what are the parts of the transistor. What are the parts of the transistor? Is it emitter, base and collector? Is it? We have emitter, base and collector. Emitter is moderate in size and will go, whereas base is lightly doped and thin. So lightly doped, whereas collector is larger in size but moderately doped. Larger size, moderate doped. Your emitter is medium in size, heavily doped. Now from the given options, which is correct one? The base region must be very thin and lightly doped. So first option is the correct one. Let us see 10th one. Here we have light with an average flux of 20 watt per centimeter square. So average flux light, which is nothing but intensity is given. Intensity of light is given here. Intensity of light I is equal to 20 watt per centimeter square. And even the given it falls on a non-reflecting surface at normal incidence having surface area 20 centimeter square. Area of the surface is equal to 20 centimeter square. The energy received by the surface during the span of time 1 minute for t is equal to but energy incident per unit area per unit time. So which is energy by area by time, which is equal to, from this one we can write energy is equal to, so we will find here energy, then IA by T. IA by T. So incident energy incident per unit area per unit time. Very clear? Is it? Now let us substitute, but we need to find what? Energy is equal to intensity. Intensity value substitute 20 watt meter power minus 2 centimeter power minus. Okay. Energy incident per unit time, which is here I is equal to, okay, let me write here. I is equal to E by A into T, but we need to find energy. Then E is equal to IA into T. Now E is equal to intensity 20 into area 20 into, because it is centimeter square by centimeter square into centimeter square, cancel, into time 60 seconds, 1 minute, which is 60 seconds. That is equal to 2 into 2 4, 4 into 6 24, then 24 into 10 power 3, 24 into 10 power 3, which is joule. We have 4000. Let us see 11th one. A short electric dipole has a dipole moment. Dipole moment is given. Dipole moment 16 into 10 power minus 9 coulomb meter. The electric potential due to dipole point at a distance x is equal to r is equal to 0.6 meter. 0.6 meter from the center of the dipole, which is situated at an angle making 60 degrees. We know potential due to point charge is equal to 1 by 4 pi epsilon naught q by r. But whereas potential due to a dipole, potential due to a dipole, so which is V is equal to 1 by 4 pi epsilon naught p cos theta by r square. That is 9 into 10 power 9 into P, 16 into 10 power minus 9 into cos 16 by r square. R is the number 0.6 whole square, or 0.6 into 0.6. Now 9 into 16, here 10 power 9, 10 power minus 9, and this cos 60 value into 1 by 2 by, let us take here 6 into 6, 36 into 10 power minus 2. 36 into 10 power minus 2. Here 8 times. Is it? Now 4, 9 fourths and 2 fourths. 9 cancel. So what we have here, which is 10 power minus goes to numerator, 10 power 2, then 2 into 10 power 2, 200 volt, then 200 volt, which is third option is correct one. Let us see next one. A ball is thrown vertically downward. A ball is thrown vertically downward, and a velocity with a velocity of 20 meters second power minus 1, and u is equal to 20 meters per second. So remember, if a body is falls freely, then initial velocity is 0. But here initial velocity is not 0 because it is thrown vertically downward. And from the top of the tower, we have a tower from this one, and the height of the tower is h. And it hits a ground of sometime with velocity of 80 meters per second. The height of the tower we need to find, and it falls under acceleration a is equal to g. Now from the equation v square minus c square is equal to 2as. S is nothing but distance traveled. Then h is equal to V square minus C square by 2 into G. A is nothing but G. Now you substitute 80 square minus 20 whole square by 2 into 10. That is equal to 6400 minus 20 square, 400 by 20. That is equal to 6400 minus 400, 6000 by 20. Then that is equal to what? 300 meter, which is first option. Second one, which is related to the resistance wire meter bridge. A resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in right gap at a point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 ohm, then the length of 1 ohm resistance. We have a meter bridge. Here the length of wire. So wire in left gap of a meter bridge balances a 10 ohm resistance. Here 10 ohm resistance. A resistance wire is connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap. So here 10 ohm resistance in the right gap. So let us R, we don't know. S is equal to 10 ohm. At a point which divides the bridge wire in the ratio 3:2. This ratio, by which is nothing but it is 3 parts. If you have taken 3 and it's 2 parts. So when we have taken from here, we have galvanometer. Now this is a jockey. Now it is L1, L2. Then L1 is 2, L2 is equal to 3 is to 2. Even if the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire. Here this wire is having 1.5 meter. Is it okay? This wire resistance is what? 1.5 meter. Then for 1 ohm, what is the resistance value we need to find? Now from balancing condition of the resistance network, balancing condition of resistance network. What is according to balancing? P by Q is equal to R by S. Or here R by S is equal to L1 by L2. So R by S is equal to L1 by L2. Is it? Now let us see R is nothing but R by S is 10 is equal to 3 by 2. Then R is equal to 30 by 2, which is 15 ohm. Now R value is 15 ohm resistance. That means 15 ohm resistance of length what? 1.5 meter. 15 ohm resistance while length is what? 1.5 ohm. Sorry, 1.5 meter. Then for 1 ohm, what is the length? Is it okay? Then what we can write? Length is equal to 1.5 by 15. That is equal to here what? 10 times 1 by 10, which is 10 power minus 1 meter. 1 into 10 power minus 1 meter, which is third option. So 14. When uranium isotope 92 uranium 235. So this is what basic reaction for nuclear fission is bombarded with a neutron. So plus 0 and 1. Now it gives rise to, it generates krypton. This is 36, krypton 89, and even they have given 3 neutrons. 3 neutrons, 3, 0, and 1. Now, what would be the another product? Is it? We need to find what? Now look at this one, 36 on the total mass number and atomic number on both sides of the reaction should be same. Here we have 92 and this side we have 36, here 0, then x plus 36, then x is equal to what? 92 minus 36, which is equal to 56. Now 56, which is barium. 56 barium. Now what is mass number? Here right side we have total 125 plus 1, that should be equal to, here we don't know y, so y plus 89 plus 3, 89 plus 3, then y is equal to 236 minus 92, that is equal to 144. Now 144, 56 bearing 144 is the product, and the product along with the krypton and the neutron. So we have here second option. So let us see 15th one. A long solenoid of 50 centimeter length. So length of the solenoid is 50 centimeter, which is 0.5 meter. Having 100 turns, carries a current of 2.5 ampere. So number of turns are 100 and carries a current of 2.5 ampere. The magnetic field at the center of the solenoid. So let us see what will be the magnetic field at the center of the solenoid. Magnetic field at the center of the solenoid, mu naught Ni. Is it? N is represents mu naught into N represents number of turns per unit length into current. Then mu naught value is 4 pi into 10 power minus 7 into, what is the total number of turns here? 100 by 0.5 into current is here 2.5. Now you see that here the pi values also substituted. Then you need to see 0.5, which is nothing but 1 by 2 if it goes to numerator into 2, then 2 into 2.55, 5 into 4, 20, then 20, out of 20 I have taken 110 here, 100 into 10, 1000, 1000 into 10 power minus 7, 10 power minus 4. Now here we have 2 into pi, which is 2 into 3.14, 6.28 into 10 power minus 4 Tesla, which is second option. Let us see next 16th one. The average thermal energy for a monatomic gas we need to find. The average thermal energy of monatomic gas, which is F by 2 kBT. So what are the degrees of freedom for monatomic gas? 3. Then what we have here? 3 by 2 kBT, which is third option. Let us see 17th one. A capillary tube of radius r is immersed in water and raised to a height, but the mass of the water is 5 gram. Now another capillary tube of radius 2r is immersed in water. The mass of the water we need to find here. Capillary tube of radius small r and which is immersed in water and raised to a height h. In this case, the mass is what? 5. Now another capillary tube of radius 2r which is immersed in the water, then it rises to the rise of level is not given, and the mass of the water that will rise. What is the mass of the water? M2 is equal to. So we know which is based on surface tension properties of the fluids. 2T cos theta is equal to H naught rho G. Is it? Now tension in this one is nothing but which is rises, that is due to what amount? Here T cos theta component 2T cos theta which is equal to mg. Then this is nothing but here what? Mg is equal to H r rho. Now remaining all are constant. Then m is directly proportional to what? Radius. We need to find here m2. R1 is r, r2 is 2r. R1 is equal to r, r2 is equal to r. Now m2 by m1 is equal to r2 by r. From this one, m2 is equal to r2, 2r by r into m1 5, that is equal to 10 gram. Is it? 10 gram, which represents that what option is it? Fourth option. Is it 17th one? What? Fourth option. Let us see 18th one. So the ratio of contribution made by the electric field and the magnetic field components to the intensity of an electromagnetic wave is it here? The energy, total energy of the electromagnetic wave is due to the energy due to electric field and electricity due to magnetic field. So they will be have 50% contributions. Then what will be the ratio? 1:1, which is will get third option. Are you clear? Third option. Let us go for 19th one. Assume that the light of wavelength 600 nanometer is coming from a star. The limit of resolution of the telescope whose objective has a diameter 2 meter. Assume that the light of wavelength is given 600 nanometer. So lambda is equal to 600 nanometer, and even from the limit of resolution, diameter of the objective, which is d, that is equal to 2a, is equal to 2 meter. Now 600 nanometer means 600 into 10 power minus 9, which is 10 power minus 7 meter. Now what is the limit of resolution of telescope? You may confuse with the microscope. For microscope, 1.22 lambda by 2n sin meter. But here, limit of resolution, the minimum is equal to 1.22 lambda by 2a, which is the given diameter of the aperture. Then 1.22 into 6 into 10 power minus 7 by 2. Here it is what? 3 times. Then 3 into 1.22. 3.66 into 10 power minus 7 meter. Which is second option, partial resolution, which is in radian. So let us go for the 20th one. A wire of length L, area of cross section A is hanging from a fixed support. The length of the wire changes to L1 when M is suspended from it. The expression for Young's modulus is given. Initial length is L and area of cross section is A, and it is hanging from a fixed support Y. The length of the wire changes to L1 is L. Now it is changes to L1. When M mass is suspended, capital M mass is suspended. The expression for Young's modulus. What do you mean by Young's modulus? Longitudinal stress square, longitudinal strain. So Young's modulus is equal to F by A by delta L by L. That is equal to FL by A into delta L. Then F is nothing but what? Due to its weight. Then M into G into L by A into what is changing length? Initially it is L, but the length is increased to L1. What is changing length here? L1 minus L. Then A into L1 minus L. MGL by A into L1 minus L, which is first option. Let us see 21st one. The energy required to break one bond in DNA is 10 power minus 20 joule. This value in electron volt is nearly. Energy required. So energy is equal to 10 power minus 20 joule. But you need to find this answer in electron volt. Remember, 1 electron volt is equal to 1.6 into 10 power minus 19 joule. But 1 joule is equal to what? 1 by 1.6 into 10 power minus 19. Now you substitute E is equal to 10 power minus 20 into, instead of 1 joule, you divide. So by 1.6 into 10 power minus 19 electron volt. Now in 10 power minus 19 goes numerator plus 19, then 10 power minus 1 by 1.6, that is equal to, you multiply and divide with 10. So 10 by 1.6 into 10 power minus 2. Now 10 by 1.6 value is 6.25 into 10 power minus 2, that is equal to 0.0625 electron volt, which is fourth option, 0.06, but we have calculated even more decimals, which is 0.0625, and exact value is what? 4. Let us go for the 22nd one. The mean free path for a gas with molecular diameter d and number density n can be expressed. So which is mean free path 1 by root 2 pi n d square, which is a basic formula, third option. So let us go for 22nd one. In certain region of space, the volume given and potential is found to be 5 volt throughout. The magnitude of electric field in this region is. 22nd one. In a certain region of space, volume is given. Volume V is equal to 0.2 meter cube and electric potential is found to be 5 volt throughout, and it is what in a space, and throughout the potential is what 5 volt. Then potential is what constant. If potential is constant, what is electric field? Minus dV by dx, which is equal to 0 for constant value differentiation 0. Then we get second option is the correct one. Let us go for 24th one. An electron is accelerated from rest through a potential difference of V volt. If the de Broglie wavelength of electron is 1.27 in 10 power minus 2 nanometer, the potential difference is 23rd. So we need to find here the potential difference. Is it? What is the de Broglie wavelength? Remember, let me write here the given de Broglie wavelength as 1.227 into 10 power minus 2 nanometer, and this is for electron only. The potential difference you need to find. That potential de Broglie wavelength in terms of the potential difference, lambda is equal to 1.227 by root V nanometer. Direct formula, lambda is equal to 2 MeV. From that also you can calculate. Now you need to find V value. Then root V is equal to 1.227 by lambda, but we take the value 1.227 by lambda square. Then we write here 1.227 by lambda. Lambda value is nothing but what we know, 1.227 into 10 power minus 2 whole square, and that is in nanometer. Then even wavelength is also given nanometer. Then we don't need to go for nanometer substitution. Then 1 nano. Okay. Now 1.227 by 1.227, it is also square, sorry. Now this is also square. Then 1.27 square, 1.27 square will be cancelled. Then we have 1 by 10 power minus 4, which is 10 power 4 volt. Then which we have first option is the correct one. Let us go for the 25th one. In a guitar, two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530, the original frequency of B will be. Is it? What we have here? 25th one. In a guitar, two strings A and B made of same material are slightly out of tune, is it? And they produce beats, that is say FA difference FB is equal to 6. But we don't know which is happening, FA A is more or B is more. Now when tension B is slightly decreased, when tension is decreased, what happens to frequency decreases? Because F is equal to 1 by 2 elements square of T by mu. Then if the tension decreases, the frequency also decreases. The beat, when tension is B, so B frequency decreases. The beat frequency increases to 7 Hz. The frequency of A is 530, the original frequency of B. Now, remember, if B is having less value, when the frequency decreases, what happens to the difference? Increases. That means beats will become, instead of 6 will become 7. So we can take here FA minus FB is equal to 6. But remember, this is given 530 minus FB is equal to 6. Then FB is equal to 530 minus 6 is equal to 524. H is the correct answer. Third option. Let us go for 26th one. If 40 microfarad capacitor is connected to voltage and frequency supply, RMS value of current we need to find. A 40 microfarad capacitor, C value is given 40 microfarad, and connected to 200 volt 50 supply. But tell me, is 200 volt RMS or peak value? Nothing is mentioned, means it is what? RMS. Then V RMS is equal to 200 volt and frequency is given 50 Hz. Frequency is given 50 Hz is supply. The RMS value of current we need to find. I RMS is equal to what you know? V RMS by XC, which is capacitor reactance per capacitor. That is equal to V RMS by 1 by omega C. That is equal to V into omega C. Then V into 2 pi F into C. Now you substitute values. IRMS is equal to 200 into 2 into here 3.14 into 50 into 40 into 10 power minus 6. C value 40 microfarad and 40 10 power minus 6. Now let us find the answer. Look at this one. 4, 5, which is 20, 4 into 5, 20, 20 into 2, so 20 means 110, let me take here, first let me find 10 powers, let me take 2 into 3.14 into 5 into 4, 2, so 0 let me take, 2 zeros here, 1 0, here 1 0, 4 and one more here 5, 10 power 5, so 10 power 5 is 10 power minus 6, 10 power minus 1. Now here 2 into 4, 4 into 2, 8, 8 into 3.14, so which is 25 approximately into 10 power minus 1, that is equal to 2.5 ampere, which is 4th option, 2.5 ampere. Let us go for the 27th. The increase in width of depletion region in a PN junction diode is due to what? Increase in forward current or forward bias or reverse bias? Both forward bias. Only in reverse bias, depletion region width will be increases so that the current will be very less. Then third option only the correct one. Let us go for the 28th one. The Brewster's angle of an interface should be, so which should be in between, which is less than 90 and more than 45, which is 4th option. And let us go for 29th one. The phase difference of between displacement and acceleration of particle in simple harmonic motion. So let me explain. Phase difference between displacement and acceleration. What is displacement? Displacement is y is equal to a sin omega t, whereas velocity is equal to what? dy by dt. So a sin omega t plus y. Let me take y. Phase difference is 0. 0, okay. So a sin omega t plus y. Now a sin omega t cos omega t, is it? But sin again for omega. So let me take sin omega t. Is it okay? Now acceleration is equal to dv by dt. That is equal to a omega into cos omega t minus sin omega t. For again omega square. Now we have here positive, here negative and negative is positive. It is sin function. It is sin function. So there is what? If you have drawn the graph, this one, and this is for y and t, and velocity if you have taken, and it is which is starts from peak value, from here to be starting, and whereas acceleration is exactly opposite phase to this one. Now we will get this. Then what is phase difference? Pi is the phase difference, 180 degrees. pi radian. A spherical conductor of radius 10 cm has a charge given, and what is the magnitude of electric field at a point 15 cm from its center of the sphere. So spherical conductor of radius, we have a sphere of radius is formed 10 cm, but at a distance of 15 cm, there are asked to find electric field, and the charge which is distributed are here 3.2 into 10 power minus 7 coulomb. And what is the magnitude of electric field? The electric field at a distance we know which is outside. Inside it is a 0, but outside it is as a point charge. Then 1 by 4 pi epsilon naught into q by r square. So here we need to take small r. This is capital, this is radius. Then 9 into 10 power 9 into q 3.2 into 10 power minus 7 by 15 into 10 power minus 2 whole square. Is it? Now here we have 10 power 9, 10 power minus 7, which is 10 power 2. If 10 power minus 2 square, 10 power minus 4 goes to return 10 power 6. Now 9 into 3.2 by 15 into 50. So let us see here 3 3s 9, 5 3s 15. Again 3, here 5. Let me write here 3.2 means 32 into 10 power 5. Let me write here 10 power 5 by 25. Now 32 by 1.25, which is 1.28 into 10 power 5 Newton per coulomb, which is third option 1.28 into 10 power 5. Let us go for 31st one, which is based on again capacitances. The capacitance of a parallel plate capacitor with a air medium 6 microfarad. With the introduction of a dielectric medium, the capacitance becomes 30 microfarad. The permittivity of the medium is. So when we go to find the permittivity of the medium, 31st one, which is capacitance there epsilon naught A by D. Whereas for a medium C dash is equal to, is it what we have? Epsilon A by D. Then let us take here C dash by C is equal to what? Epsilon by epsilon naught. Now C dash is given 30 by 6. 30 by 6. That is equal to epsilon by epsilon. Here it is what? 5. Then epsilon is equal to 5 epsilon naught. Then 5 into 8.85 into 10 power minus 1. That is equal to 5 into 8.85. What do we have? Then which is 44.25 into 10 power minus 1. But options are given not in 44. Then you bring 2 decimals to this side, which will have 0.44 into 10 power minus 10, which is coulomb square Newton power minus 1 Newton power minus 2. Then fourth option is the correct one. Let us go for 32nd one. Taking into account of the significant figures, we need to find the value for this question. What is given? 9.99 meter minus 0.0099. Significant figures, which is very simple. Now here 10 minus 9, 1, and 9 minus 9, 0. Here 8 will be 8, 9. 9.90. But during the additional subtraction, when we consider the decimals, so when we have with the significant figures, the resultant value must have the number of decimals as least in the given value. So out of this one, which is the least decimal, only 2 decimals, then the resultant must be rounded to the 2 decimals. Then 9.98 is the correct answer. third. Let us go for 33rd. A series LCR circuit to an voltage of source. When L is removed from the circuit, the phase difference between current and voltage is pi by 3, and if C is removed, then the phase difference pi by 3. The power factor of the circuit we need to find. A series LCR circuit when voltage source, when L is removed from the circuit, the phase difference between the current and voltage is pi by 3. That means pi 1 equal to pi by 3. When L is removed, L is actually we know tan pi is equal to Xc minus XL by R. Now, if L is removed means what? We will not consider this one. Or even you can take tan pi 1 is equal to what? Xc by R. When L is removed. Now, when C is removed, then tan pi, that is what? XL by R. But these two values are remaining same, only tan pi 1, tan pi 2. Then what we have here? Xc by R is equal to what? XL by R. Then Xc is equal to XL. That represents what circuit is it? Resonant circuit. Resonant circuit. For LCR resonant circuit, what is value? Cos pi, power factor. Power factor. So here impedance is equal to what? R. Now cos pi is equal to what you know? R by Z. R and Z is 1. And power factor is equal to what? 1. Which is 4,000. Now let us go for the next one. Dimensions of stress are. What do you mean by this stress? Stress is nothing but tangential force acting per unit, which is nothing but pressure. Then mL t power minus 2 by area L square. Then mL power minus 1 t power minus 2 is the dimensions. Let us go for 35th one. Light of frequency, which is dual nature. In that light of frequency 1.5 times the threshold frequency is incident on photosystem here. Now incident frequency 1.5 times of the threshold frequency on photo. What will be the photoelectric current if the frequency is offed? Now incident frequency will become what? Mu naught by 2. What will be the photoelectric current if the frequency is offed and the intensity is doubled? Okay, frequency is offed means what? 1.5 by 2. So 1.5 mu naught by 2, that is equal to 0.75 mu naught. But the intensity is here, I means here the intensity is doubled. I dash is equal to I naught to I naught. Remember, the photoelectric current does not depend upon frequency if it is more than threshold frequency. But remember, here incident frequency is less than threshold frequency. Then do you get any current, electric current? No electric current flows. Then the photo current will become what? 0. Photo current will become 0. So that is what? Even if this happens more intensity, if the incident frequency is less than threshold frequency, then the electron cannot be emitted from the surface of the metal, so that no photo current will be takes place. Then current in that is 0, which is first option. So let us go for 36th one. The solids which have negative temperature coefficient of resistance are, so what? Which you know already this one. 36th one. Negative temperature of coefficient of resistance are the temperature. So positive for metals, whereas there is no change for alloys. Negative for insulators, for semiconductors. So which is first option is the correct one. Now let us go for the next one. A charged particle having drift velocity of 7.5 into 10 power minus 4 meter second power minus 1 in an electric field 3 into 10 power minus 10 voltmeter inverse. Find charged particle drift velocity Vd is equal to 7.5 into 10 power minus 4 meter second power minus 1, and electric field is given 3 into 10 power minus 10 voltmeter inverse. Then mobility, what is the formula for mobility? Drift velocity for unit electric field, Vd by E. Vd 7.5 into 10 power minus 4 by E is 3 into 10 power minus 10. Is it? Now what we have? 2.5. 7.5 into 2.5 into 10 power minus 10 goes to 10 power plus 10 into 10 power 6. Is it? Then meter square volt power minus 1 second power minus 1, which is third option. Let us go for 38th one. Which of the following graph represents variation of resistivity rho with temperature T for copper? So the nature of the graphs is given, and it is directly answered textbook question. 38th one. Look at this. We have for copper it does not be like this for copper. And whereas we have seen for nichrome, what is that one? Nichrome resistivity with temperature. So then what we have? Third option is the correct one for copper. Third option is correct. Sorry, we have fourth one. Fourth one is correct. Whereas for insulators, what will be happening? This is for nichrome. So whereas for semiconductor, if the temperature increases, the resistivity will be decreases. Rho is equal to m by Ne square T. Number density of electrons will increases. So therefore, the resistivity will be decreases. And for this one we have fourth option is the correct one. 39th one. Here we have two masses and pulley. From pulley we have two masses 6 kg, and here we have 4 kg. Let us take M1 and this M1. Now the acceleration of the system in terms of acceleration we have, you know already. A is equal to direct form we have m2 minus m1 by m1 plus m2 into g. So which is having 6 minus 4 by 6 plus 4 into g. Then 6 minus 4 2 by 10 into g. Here it is 5 times, that is equal to 1 by 5, which is g by 5. Fourth option is the correct one. Let us go for quad wave, which is based on least count. So screw gauge has least count 0.01 meter. Number of divisions given and asking pitch of the screw gauge. What is the least count formula? Least count is equal to pitch of the screw by number of divisions on circular scale. Divisions on circular scale. Now that is equal to, but we need to find here pitch is equal to least count into number of divisions. Least count is given 0.01 and number of divisions here given 50. That is equal to 0.1 into 5, 0.5 millimeter, because this is in millimeter and also we get in millimeter, which is 0.5 millimeter. We have fourth option. Let us go for the first one. In Young's double segment, separation between the coherent source is of distance of the screen coherent source double, then the fringe width you need to find. Separation between the sources is double of d by 2 b dash. Whereas what happened? Distance of the screen from coherent source is doubled. So d dash is equal to 2d. Now what is the fringe width? we know fringe width is equal to fringe width beta is equal to lambda d by d. Then beta 2 beta dash by beta is equal to directly proportional to capital D, d dash by d into d by d dash. Now what we get here, beta dash is equal to beta into d dash 2d by d into d by d by d. That is equal to d cancel, d by 2 will become d, then 4 into beta, then we get 4 times, which is fourth option correct. So for the logic circuit shown, the truth table given, and we need to find the correct options from 1 2 3 4, and this represents which is nothing but NOR circuit. Let us find which option we will get. 42nd one. We have now if you are taking A, B, now NOT gate, A naught, B naught, and again it is NOR gate. What you get here, Y is equal to A naught or B naught, again naught. Is it? So A naught, B naught, it means A and B. A naught naught and B naught naught, which is nothing but AND circuit. Is it? Now AND circuit, for AND circuit what is that one? If both of the inputs are high, then only the output is high. So from Boolean algebra we can write De Morgan's theorem, A naught or B naught naught is equal to A naught naught and B naught naught, that is equal to A and B, which is AND gate. Then you will get now A, B, Y. A 0 means Y is equal to what? 0. And even if any one of the input is high, output is 0. Both the inputs are, if any one of the low, output is low. Both the inputs are high, then only the output is high. Then 1 0 0, 1 1 1. So which is what option we have? Second option. So let us go for the 43rd one. The energy equivalent to 0.5 gram of substance, which is very easy. From Einstein's mass energy equation, what we thought, E is equal to 0.mc square, then 0.5 into mass, you have converted into kg, then 10 power minus 3 into 3 into 10 power 8 whole square. Is it? That is equal to 1 by 4 into 10 power minus 3 into 9 square, 3 square, 9 into 10 power 16. 1 by 2, 9 by 2, 4.5 into 10 power 13 joule, which is third option. And 44th one, which is based on Bohr's model, limitations of Bohr's model. For which one of the following Bohr model is not valid? For single ionized neon atom is not valid. For single ionized helium atom, hydrogen atom, deuteron, for all these only one electron, so it will be valid. But for single ionized neon, it is not valid. So first option is the correct option, means it is not valid for neon. Now let us go for 45th one, which is the last one. The quantities of heat required to raise the temperature of two solid copper tubes, radii R1 R2 through 1 Kelvin, you need to find. Ratio of the heat. What is the value of the heat energies? Heat energies. We know Q is equal to mc delta T. As it is a sphere, okay, mass is nothing but density into volume into specific heat capacity into change in temperature. Now Q. But remember, density is same, specific heat capacity is same, and for the both of those raising temperature 1 Kelvin. But what about volume on sphere? 4 by 3 pi r cube. 4 by 3 pi r cube. Then Q is directly proportional to what? R cube. And even they have given R1 is equal to 1.5 R. Now what is the ratio? Q1 by Q2 is equal to what? R1 by R2 whole cube. Now R1 by R2, which is 1.5 1.5 is nothing but you can write 3 by 2. Now 3 cube 27 by 2 cube 8, which is 27 is to 8 is the second option is the correct one. So these are the solutions with detailed concept and formula based only. We have all the problems which are based on formula. So only if you are based on the concept. Now as the paper was very easy, but even the cutoff also very the marks cutoff for maybe around 450 or 400. So that is based on the categories and the states, and even we can see that. And the predicted ranks around for 500, it is around 25,000, whereas for 550 we are getting around 80, 510 we are getting 11,000, 18,000, and whereas for 550 we are getting around 8,000, 9,000. So that is because of the paper was very easy. The rank expected to get the good college, esteemed colleges in the India, we need to get good score. Thank you. Very good. So please go through this one and check the key. Thank you.